Hi student. Today let's we discuss about the derivation of a current of a decay in LR circuit. So this is the syllabus of a SCP physics third chapter. This is physics third sem of a second year. So let's we derive for a decay current of a LR circuit. Consider inductance and resistance are connected to the battery through the key K1. So when you key and connected K2 key for the decay purpose, when EMF is applied, the voltage through inductance and voltage across resistance can be sum is given equal to the total applied voltage, that is given by E equal to VL and VR. VL is the voltage across resistance, VR is the voltage across resistance. So as we know that the voltage across the inductance is given by the L into di by dt and the VR is I into R. When K1 is closed, when K1 is closed, current flow through the circuit and charges up to maximum level and become constant. When K2 is closed, then when K1 is open and K2 is closed, then current start to discharge through the K2 key. Then E is the 0. Then put this equation in 1. Then we get in equation 1 E tends to 0. That is E tends to 0. Hence equation can be written as 0. This is the voltage across inductance and voltage across IR. Just rearrange this one with this brought to this left side. Then di by di and L is cross over, that is minus R by L. After integration, this one integrate, then we get log I minus RL by dt with respect to dt, that's why it is t, and some constant plus c. Let it be equation 2. For the calculation of the constant c, we put the at time t0, then current I is I0 because we are already charged to a highest level, that is the maximum current, and we then start to discharge, that's why I tends to I0. So C gets the value of log I0 when t tends to 0. So C gets to I equal to I0. That's why then put this equation of the C value in the equation 2. That's we got and simplify log I by I0 is equal to minus R by L into t. On simplification, I is equal to I0 e to the power of minus RL into t. This is the gives the decay of current in LR circuit. This is the current expression. So if we discuss when some in cases and t is 0, the I is maximum. When t is infinity, I tends to 0 because it goes on decreasing like this, and we can write in graph current versus time, that is gives the current first at 0 time it's a maximum increases, after some time the current goes on decreasing and reaches to infinity. That's why after time infinity I tends to 0. Here the time constant tau is equal to L by R. So It is the time constant to reduce the system by 36.8%. That is, when put this two value here, I equal to I naught e to the power of minus 1, when put equation 3, then I naught is 1 by e, and I naught is 1 by e value is 2.718, 2.17. When divide this 1 by 2.78, I naught get the 0. This one. So that is 0.36. That is the percentage is 36 of the maximum current I naught. So that is they are called time constant. The time constant is the in a decay current is the time required for the current to reach the 36.8% of its maximum current, and it may be reached to current 0 when tau is 5 into 5 times of their time constant. Hence this is about the decay of current when a circuit L and R in circuit, the current goes on decreasing and reaches 0 when it is time infinity. Hence this is called